All right, guys, time to do the quads test review. I'm going to work through it kind of quickly. I'm hoping we're a bit stronger at some of this stuff now. I'm not going to write this on every single section, but you do need to know what the tree looks like. These are hard questions if you don't know the trees and you don't know what properties happen in which shapes. So we've talked about this several times. Some of the big ones are kites. Kites have rights somewhere inside, perpendicular diagonals. Isosceles trapezoids have congruent diagonals. Isosceles means two equal sides, but also two equal diagonals in this case. Parallelogram, the diagonals bisect each other. And then finally, the rhombus, the diagonals bisect the vertices. These are things, like there's other things that go on, but these are some of the main things people forget are these diagonal properties. I've already selected the answers. I will tell you that they're random order, so pay attention to what it says, not where it is. So what properties first appear in the rhombus? There's two of them. We have four equal sides, and the diagonals bisect the vertices. So can you have four equal sides and not be a square? Yes, you can. A rhombus has four equal sides, and it's not a square. Rectangle only has one property that's never shown up before. All angles must be equal. They have to all be 90 degrees. Here is a rectangle. All the angles are 90. That's not a square. So in order to get a square, you have to have all angles and all sides congruent. People keep confusing that. Come on now. Let's get that down. So all angles are congruent. That's the only new property rectangles have. It does have a really cool thing, though, in that it has congruent diagonals and they bisect each other. So when you draw a rectangle, this is going to be important later. When you draw a rectangle, we know that like if this is 10, this would also be 10 because they bisect each other and they're equal. So the other one would also be 10 and 10. So that's the first time they're cut in half and equal. But that's not like, those are both borrowed properties. Trapezoid, isosceles trapezoid has congruent base angles and diagonals that are congruent. And then the kite, the main thing it brings us is that the diagonals are perpendicular now. We're still going. Five things. Parallelogram has five things. Consecutive angles are supplementary. That means if you were to draw a parallelogram, boop. I'm going to draw one real quick here. So if I draw myself a parallelogram, oops. There we go. Consecutive angles are supplementary. That means angles 1 and 2, 3 and 4. They're going to add up to 180. So, 1 and 2 are going to add up to 180. 2 and 3, 3 and 4, and 1 and 4. It happens in every direction. So that's what I mean by consecutive angles. Diagonals bisect each other. Opposite angles are congruent. Opposite sides are parallel. Opposite sides are congruent. And remember, if any of those happen, if any one of those happen, they all five happen. All right, now we get to do some work. It's a rhombus called Mary. Mary had a rhombus, rhombus, rhombus. Mary got on the rhombus, huh? Lost her lamb? I don't know what she did. Okay, so we got a rhombus. It's called Mary. It doesn't matter where you put the letters. Just make sure that once you start naming them that you go in counterclockwise or clockwise. So I went clockwise, but I could have gone counterclockwise. And they intersect at B. That means that this point is B, not this angle. It's not angle B. It's vertex B. Make sure we remember that. It says MR is the short diagonal. Well, okay. Let's fix that. Mary had a little lamb. All right. Now, MR is the short diagonal and has a length of 12. Well, it's a rhombus, which means it's a type of parallelogram. So if the entire thing is 12, that means each part's going to be 6. It says MY is 5x plus 27. And angle RBY, that's this guy right here. I'm not going to write it in there, but this little angle, we know it's 90 degrees. So what do we know about this angle? RBY has to equal 90. So let's get going. 6x plus 108 has to equal 90. So 6x has to equal negative 18. So x is negative 3 on this question. All right, so that's pretty helpful because if x is negative 3, then this is negative 15 plus 27. This is 12. So we know that the side length is 12. And if we recognize this pattern, so if I look at this right triangle, let me draw it over here. We have 12 and we have 6. Well, isn't that the 30, 60, 90 pattern? You could do Pythagorean theorem if you wanted, but if this is the 30, 60, 90 pattern, right? 12 divided by 2 is 6, right? If this is 12 divided by 2 is 6, well then times root 3, this is going to be 6 root 3. But keep in mind, they want the length of the entire diagonal. That's why it's 12 root 3. 6 root 3 is half the diagonal. Question 7, determine if these are sometimes, always, or never true. I said I wasn't going to keep drawing this, but you really need to have the tree. I hope you know how to use the tree. I bet you do. Oh, wait. Oop, let's go way down here. So we got rectangle, rhombus, and square. You have to know what properties happen when. This can be really tricky. Let's go. We can do it. Opposite sides of a kite are congruent. Well, let's start with just opposite sides are congruent. That's my parallelograms. And it has to be a kite, right? They said it's a kite. So if I, forget all this for a second. If I just said opposite sides of a kite are congruent, what shape is that? Ooh, it's got to be a rhombus. So this first section is code for rhombus. Well, so if it's a rhombus, are the opposite sides parallel? That's always, right? And actually, you could even take the word kite out of here. If opposite sides are congruent, that's a parallelogram property. Then opposite sides are parallel. Yes, remember, if one of them happens, they all 5 have to happen. So yes, that's always true. The sides of a square add up to 360 sometimes. So a square, the angles are 90 every time, right? Whoop, all those 90. But could the sides also be 90? Yeah, they could. They don't have to, but they could. So sometimes. A trapezoid is a square. Well, here's all the trapezoids. Are any of those squares? Yes, one of those is a square. Are all of those squares? No. So it's sometimes. A rectangle is a trapezoid. So here are my rectangles. Here are my trapezoids. We're focusing on the rectangles. Are those all trapezoids or just some of them trapezoids? Well, all of them are trapezoids. A rectangle is a trapezoid and a square is a trapezoid. So everything that classifies as a rectangle also classifies as a trapezoid. Always. The diagonals of a rhombus bisect each other. Diagonals bisect each other. That's a parallelogram. Well, is a rhombus a type of parallelogram? Yes, always. And then the diagonals of a parallelogram are congruent. Here's my parallelograms. Over here, we have congruent diagonals. So does every parallelogram have congruent diagonals? No. There are 2 shapes classified as parallelograms that don't have congruent diagonals. But 2 of them do. So that's sometimes. What is the most descriptive shape? Well, we're going to use the same tree because I don't want to keep drawing it. Same tree. The diagonals of a parallelogram are congruent. The moment I call it a parallelogram, you better give me one of those 4. The diagonals are congruent. The first time that happens is rectangle. A parallelogram with congruent diagonals, you must call a rectangle. What about the square? It could be a square. I know. And when I call it a rectangle, could it still be a square? Yes. But it must be a rectangle. I can draw rectangles that are not squares where this is true. The diagonals of a parallelogram are perpendicular. Once again, here's my parallelograms. Perpendicular diagonals are over here. So what shape is that? Oh, rhombus. Rhombus is the first time we have both. The diagonals of a trapezoid are perpendicular. Okay, a bigger net, trapezoid, and perpendicular. But guys, if I say the diagonals are perpendicular, there's only 3 answers. It's got to be one of those 3, and you always stop at the top. The first one it is rhombus. You stop at the top, let's go. So that's rhombus again. And the opposite sides of a quad, that's the whole tree, are congruent. Well, when are opposite sides congruent? That's one of parallelogram's core properties. All right, we got a rhombus. How do we draw a rhombus? We start with an isosceles triangle, and then we reflect it. It's the same isosceles triangle. Obviously, I'm not doing it perfectly, but it just needs to be close. And it says that one corner is 36. Well, if the entire corner is 36, what happens when you cut that in half is you get a couple of 18s. And I didn't know which one, but I made the one that looks smaller be smaller, right? Because if those are 18, aren't these other angles 72? And so I want the, if possible, if I have control over it, I'm going to make the big angles look big and the small angles look small. If the long diagonal is 30, well, good thing I drew it to scale. So the long diagonal is 30. That means each part, because it's cut in half, has to be 15. What is the length of the short diagonal? So I'm going to shift my focus to this right triangle where the short diagonal would be 2x. So I need to find 1x first. 15, 18, and 72. So I could do the tangent of 18 equals x over 15. So x equals 15 tan 18. Right? That's opposite over adjacent. We need to know our trig rules for sure. So what is 2x? What is 2 of those? Well, that would be 30 tan 18. So that's one answer. And it looks like just from the answer choices that there's other ways they approached it. But sine, cosine, tangent, those are out. Sorry, sine and cosine are out. We don't have a hypotenuse. But there's some other tangent ones. Let's see what we can do. Could I use the 72 and do opposite over adjacent? Yeah. The tangent of 72 equals 15 over x. If x is down low, they switch places, you know. So that would be 15 over tan 72. Oops, I wrote that backwards. Tan 72. So 2x, 2 of those, right? We have to have 2x, the entire distance across, would be 30 over tan 72. And so those are the two answers. I don't see any other ones that would work. Yeah, based off the answer choices, that's it. There are more ways to do it, but that's it based off the answer choices. All right. Consecutive sides are of a parallelogram. So I'm going to draw a parallelogram here. So we got our parallelogram. And it says that consecutive corners are 2x minus 10. And 3x plus 22. Does it matter which consecutive corners I pick? No, right? Like consecutive corners, consecutive corners, consecutive corners. I could pick any of the four. What's true about consecutive corners of a parallelogram? No matter what, they're going to add up to 180. So we know that consecutive corners, 2x minus 10 and 3x plus 22, are going to add up to 180. So 5x plus 12 is 180. So 5x is going to be 168. So x is going to be 168 over 5. What is the size of the biggest angle of the parallelogram? You may type it as a fraction or a decimal. I put the decimal one there. Make sure I got it right. 168 over 5 is the smaller angle. No, sorry, that's x. So I got to plug that in. Good thing I typed it in. So that's what x equals. So I plug that in, right? So I'm going to store that into x. And so it could be 3x plus 22. This would be 614 over 5. Or 2x minus 10. And this would be 286 over 5. Well, which one's bigger? The 614 one is the bigger one for sure. And that equals 122.8. So you could type it either way. It says it'll take the fraction or decimal version of the answer. So I had to solve for x and plug it in. Plug it in, plug it in. In the following kite, Katie is 44 feet. Well, just looking at the kite, if these two sides are equal, that because we know about the rules of a kite, we know there's a line of symmetry. So the line Katie is going to reflect over that line of symmetry. If the whole thing's 44, we're going to get a couple of 22s. And then we have a big kit over here, KIT. Kit is 36. Again, this corner would be folded in half. So if the entire corner is 36, it's going to be a couple of 18s. And it says the opposite angle is double that size. So these are going to be a couple of 36s over here. If this corner is 36, this corner has to be 72. And again, they're cut in half because a kite is folded in half. This is my line of symmetry. So that it's folded over that line. Find the length of it. Well, we got to find it. I'm going to call it x. So if I focus, so they gave us a kit to solve for it. We can do this. So if this is 18 and this is 22 and I need it, That's going to be opposite over hypotenuse. So that's going to be the sine of 18 equals 22 opposite over hypotenuse. If x is down low, they switch places, you know. And so that's 22 over, let's type that in, 22 over the sine of 18. I get 71.193. Boom, boom, boom. ACDF, that's this big boy here, is a rectangle. Okay, so we got 90s in the corners. FBDE, that is a rhombus. Okay, so if that's 120, this is going to be 120. Rhombus, all four sides are equal. So if that's 120, then these two corners have to be 30. Right, because that's an isosceles triangle, so 180 minus 120 divided by 2, those have to be 30. Because the rectangle, this has to be 60, and 60 because the corner is 90. Focusing on this small triangle, if that's 60, this has to be 30. And over here, again, same idea. If that's 60, this has to be 30. This will be 30, this will be 30. Okay, I'm kind of going away from myself. What are we actually trying to find? Solve for x. I don't see x. Oh, this entire side is x. All right, well, the only number they gave us is this 5 over here, and it's across from a 30. So this would be 5 root 3, and this would, because it's a rectangle, this would be 5 as well, making this also 5 root 3. So what is x? 5 root 3 plus 5 root 3. Nice, love it. Moat is an isosceles trapezoid. So I'm going to drop it like it's height, drop it like it's height. Guys, when I see these trapezoids, I just instantly cut off the wings. Get those wings out of here. Find two things, the length of OA and the measure of angle MOA. Whoa, I get that angle real fast. If it's isosceles, we know that the wings are actually the same size. So this wing and this wing are the same size because of the isosceles, meaning this is 22. And so 180 minus 22 would be 158. So this entire corner is 158. So we got that. But we also want OA. I'm going to call this X. What do we know? Well, this middle part would be 10, right? Between the two heights would be 10. And because it's isosceles, won't the wings have to be the same size? So 22 minus 10, that means these have to be 6 each, right? 6 plus 10 that equals my 22. So really, I'm working on a right triangle with a 22 and a 6, and I'm looking for the hypotenuse. So that's the sine of 22. No, that's not the sine of 22. This would be adjacent over hypotenuse. That'd be cosine of 22 would equal adjacent over hypotenuse. X is down low, they switch places, you know. So that would be 6 over the cosine of 22, 6.471. Nice. Polygon questions, big rules. The interior sum is n minus 2, which is the number of triangles, times 180. We've talked about that. The exterior sum is 360. Knowing those two things, we should be able to logic our way to every detail here. So I'm going to go real fast to this, but if it's a decagon, you're going to do 8, right? That's n minus 2 times 180, 1440. If it has 4, that's a decagon. We just did that. Okay, let's pretend that's not the case. How would you undo this formula? You would start with 1440. You would divide by 180, right? Cancel that out. And then you would add 2. Cancel that out. So divide by 180, add 2, and that will get you back to 10, right? We subtracted 2 and multiplied by 180 to get there. So we divide by 180 and add 2 to go home. An exterior angle is 7.2. What's the interior sum? Well, if the exterior angle is 7.2, remember that I plus E equals 180. So it'd be 180 minus 7.2. That's going to be 172.8. I don't want to be wrong on camera. Let me do that in the calculator. Yeah, 172.8. So that's how big what am I doing? What am I doing? I don't need to do that. If one angle is 7.2, can't I do 360 divided by 7.2? 360 divided by 7.2, how many of them do you need? You need 50 of them. Okay, so there's 50 of them. Well, since I already got this angle, couldn't I just do 50 times 172.8? And that gets me 8640. Or could I do the formula from before? Could I do 48 times 180? Would that get it done? Yes. Either way, you're getting 8640. But yeah, I should have taken 360 and divided by 7.2. That's how many sides there are, right? If they have to add up to 360, it would take 50 of them. Each interior angle is this. How many sides does it have? Well, if that's the interior angle, I would do 180 minus 176. I would get 4. So now we know that that equals E, right? So the exterior angle is 4. So then I would do 360 divided by 4, which is going to equal 90. There has to be 90 sides to make that work. A hexagon has interior angles that measure those things. Oh, those are interior angles. So I would do 4 times 180. And that'd be 400 plus 320. That's going to be 720. So what do these angles have to add up to? 720. So 100 plus 90 plus x plus 8 plus 2x minus 20 plus 22 plus 16. Add them all together, right? That's 1, 2, 3, 4, 5, 6 angles have to add to 720. So let's clean that up. This would be 100 plus 90 minus 20 plus 16. And then I would have 1x, 3x. So I have 3x plus 186 equals 720. So 3x, subtract that over, 720 minus 186, I get 534. Divide that by 3, I get x equals 178. Uh-oh. I made a boo-boo. What did I forget? Let me type it again. Oh, I mistyped it. I mistyped it. Let's go. Let's try that again. So that'd be 194 equals 720. And so 720 minus 194 is 526. Wait. Something's not right. 100 plus 90 plus 8 minus 20 plus 22 plus 16. That's 216. Boop, 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 boop. So I'm trying to go too fast and I'm not paying attention to details. Has anyone else ever done that? Yeah. I just didn't type in all the numbers correctly. So now I got it. So what does 3x equal? 720 minus 216 is 504. Now let's try it. Divided by 3. There we go. Now we got the right answer. So that was just me not thinking clearly, but it is 168. All right, that's a good lesson. Pay attention to your numbers. I see that all the time. So on the quiz a lot where I could say minus 20 and people do plus 20 or just leave off the 20. I forgot to do a few things. I don't know where my first number came from. All right, so we got a trapezoid called MNOP. So trapezoids, we got two parallel sides. Now the legs, it does not say isosceles trapezoid, it just says trapezoid. It says MN and OP are the bases. So I need MN to be a base and OP. So trapezoids and kites, you have to pay more attention when you're labeling them. Do I have MN and OP as my bases? Yes, I do. Angle M is 2x plus 15. Angle P is 3x minus 10. Well, because of parallel lines, those are going to add up to 180. 2x plus 15 plus 3x minus 10 is going to equal 180. So that's going to be 5x plus 5 equals 180. 5x equals 175. 15, 20 would be 35. X equals 35. Let me type it in just in case. Got it. How big is angle P? So times 3 minus 10, I get 95 degrees. That means this one's going to be 85, but that's the one we want. So I did not draw my picture to scale, but that's okay, right? The small angle is actually big, and the big angle is actually small. Not a big deal as long as you use the numbers correctly. Do you think I'm a cat? It's just kind of a joke, guys. Pick any of the answers. All right, isosceles trapezoid A, B, C, D. So this is another trapezoid, and we have to get the bases correct. This one's isosceles, so we know more about it. But the bases are A, B, and C, D. Well, we can't mess that up, surely, right? A, B, C, D. Does everything check out? Yes. The height is 10 feet. Of course, I'm going to drop my height over here. You got to fight for your height. So that's going to be 10. AB is 15. Boink. I'm going to drop this height too. I got a feeling. This is going to be 15. DC, the whole thing is 25. Well, the middle part's 15. So it means the edges are going to be 5 each. How long are the legs? Well, that's just a Pythagorean theorem. Let's practice without a calculator. If that's 5 and 10, divide by 5 would be 1 and 2. Be the square root of 1 squared plus 2 squared. That's the square root of 5. Multiply the 5 back in. That's going to be 5 root 5. Got it. Kite Gabe. To draw a kite, you start with an isosceles triangle, and then you draw a different isosceles triangle. And what happens is you'll end up having one line of symmetry and not two. So here's my kite. It's called Gabe. But again, you got to get it right. GE needs to be equal to GA. So if I call this G, this could be GE and A. That would leave me with B down here. Is it called Gabe? G-A-B-E. Yep, everything checks out now. The measure of GEA is 38. So this little angle is 38. It's a kite, so it has rights. And E is 22. Well, based on the kite here, that means it's cut in half. The line of symmetry is vertical. So that's going to be 11 and 11. And we're looking for this. I'm going to call it X. Well, it folds left over right. This would also be 38. And so we're going to use this right triangle.
Next club photos.
So we got 11 and X. This is going to be 38. That is the cosine of 11. Nope. Of 38 degrees equals 11 over X equals adjacent over hypotenuse. Boom. So 11 over the cosine of 38 is 13.959, and we got it. Oh, a lot going on here. Before I even read the question, I'm going to fill in every angle I know. 22.5, I'm going to go alternate interior. So this is 22.5. 35, I'm going to go alternate interior. So this is going to be 35. 24.95, same thing. This is going to be 24.95. Now, this is a parallelogram, so this corner and this corner, those are consecutive corners of the parallelogram. Those have to add up to 180. So I'm going to do 180 minus 35 minus 25 minus 24.95. 180 minus 35 minus 25 minus 24.95, and I get... That's not 25. Guys, this is 22.5. Let's go fix that. Not my best video. Sorry. I'm trying to go a little too fast, maybe. This is going to be 97.55, which means this will be 97.55. And then can we use the triangle to get the rest of these angles? Yes. So 180 minus 24.95 minus 22.5. So this is 132.55, 132.55, and then 180 minus that, I get 47.45. I don't even know if I need all these, but I just wanted to do it. Find the measure of angle AED. Oh, we did need that. 132.55, got it. Find the measure of ACD, got it. Find the length of AC. Well, if that's 11.03, this is also going to be 11.03, so 22.06. And then what's bigger? Which diagonal? Well, we talked about this. The bigger corner, they won't always be drawn correctly, but they are this time. The bigger corner opens up to the longer diagonal. If it's a wider angle, it's going to have a longer side. So that's the situation there. Rectangle Ryan. R-Y-A-N. R-N is, no, R-Y is 15. R-N is 20. Find the measure of R-Y-N. So I need to draw that diagonal. So I want to know how long or how big that angle is and the length of NY. I'm going to call that Y. So I have two things I need to find. Well, I can find Y real quick. Let's do it old school. I'm going to divide by 5. 15 divided by 5, 20 divided by 5. So this is a 3, 4, 5. So multiply the 5 back in. That's going to be 25. And then I want this angle, right? This angle. So I'll do it on the original triangle, but the tangent of x would equal opposite 20 over adjacent 15. So x is the angle. We're going to do inverse tangent of 20 over 15. And I get 53.130. It says round to the nearest thousandths when necessary, and it was necessary. But this is a Pythagorean theorem. If you didn't do it that way, could you have done 15 squared plus 20 squared? Would that also get it? Yep. The area of a square is 256. Well, remember, area of a square is just the side squared. So 256 equals s squared. Take the square root. And so s would equal 16. So if you draw the square, we know that each side is 16. Find the length of its diagonals. Well, because it's a square, we know that these are 45, 45, 90s. So that's 1, 1, root 2. So what do you do to get the hypotenuse? You multiply it by root 2. So here, the big thing you need to know is, like, if the area of a square is s squared. So you had to take the square root of 256. That was an area. Also, guys, seriously, 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 I'm not a cat. Whew, that was a long one, but a fun one. I'll see you next time.